Welcome back to the second Surds video. In this one I'm just going to show you some of the slightly more complicated bits. I'm going to start with multiplying out a bracket. So you're going to do 3 multiplied by root 5 plus 2. And it's like you're used to doing really. So you're going to do 3 times root 5, which we're just going to write as 3 lots of root 5, like you would if this was like an x or something. And then we're also going to do 3 multiplied by positive 2, 3 lots of 2 are 6. Not too bad at all. Here's a slightly more complicated one. We're going to do root 8 multiplied by root 3 plus root 2 plus 4. So we're going to make sure we multiply the root 8 by each of those things inside. So we'll do that first. Root 8 times root 3. Well, I'm happy to go straight for, when it's like this, root 8 times root 3, I can actually multiply those together and get 24. This is the same as the square root of 24. And then also root 8 times root 2. So that's root 8 times root 2 is root 16. And it was positive. And this is root 8 times 4. So that's 4 lots of root 8. So like in algebra, when we're multiplying these things together, we put the whole number first if there is one. So 4 lots of root 8 rather than saying root 8 times 4. And if you just think about that, if I did want to write those the other way around, if I was trying to write as root 8 lots of 4, then it's a bit vague. Does that mean root 84? So we're not going to write that. And then this can just be tidied up one more step. That's root 24. Although we'll see in a moment that there's actually something else we can do with that. 16, root 16 is 4. It's the number 4. So that's 4. And then this is just 4 root 8 as well. We actually could go a step further with those, but that's coming up on the next bit. So multiplying out, pretty much like you're used to, just multiply the thing outside by each of the things inside the bracket. So we can also do multiplying out double brackets, and I do think that for these it's probably worth using a grid. You can do it some other way if you want to, but I'm just going to set myself up a little grid here. So 2 by 2 will do, because there's 2 terms in the first bracket and 2 in the second one. Alright, so my first bracket is root 5 and positive 2. Second bracket is root 5 and positive 1. So multiplying these together then, so this top one here, root 5 times root 5, well, that's just 5. Maybe you were thinking root 25, which is also true, but root 25 is 5, remember? And then root 5 times 2, that's 2 root 5s, that's positive. 1 times root 5 is just 1 root 5. But like in algebra, we don't need to write the 1 in. That's positive. And then these together, this is still the box that people mess up the most often. This box needs to be 2, because 1 times 2 is 2. If you were thinking 3, you've accidentally added them, but remember we are multiplying these brackets together. And then tidying this up. So I've got 2 root 5s and another root 5. Making 3 root 5s altogether. And then the numbers, I've got 5 and plus 2, which is 7. So 3 root 5s plus 7, like that. Here's another more complicated example. This one I'm going to try and find the area of this triangle. So I know that area is equal to a half times the base times the height. And here the base is in surd form and the height's also in surd form. I'm going to go ahead and use a grid method again for this. I think it's probably safest. So there's only 2 terms in each bit. Okay, drawing this one out quickly. Gonna watch out for that minus sign there as well when we get to that. Okay, so multiplying. Well, let's go this one first, I suppose. Root 7, square root 7, and negative 5. And then this part is 2 root 7s plus 6. So let's get this done. Right, okay, this is actually a little bit worse. So I've got 2 root 7s and I'm multiplying that by a root 7. So if I just ignore the set 2 for a minute, root 7 times root 7 is 7, but I've got 2 of that. So this is 2 lots of root 7 times root 7, 2 lots of 7, and this is 14. Okay, that's quite tricky, that. Over here, I've got 2 root 7s, and I want to have negative 5 of them, so it's going to be negative. 5 of this, if I've got 2 of them, and I want to times it by 5, that's going to give me 10 of those root 7s. Should have drawn a bigger box. 6 times root 7, that's a bit nicer. That's 6 root 7s. And then this box, 6 5s are 30, but is negative. So popping these bits together then. So the square root bits, I've got 6 root 7s and I need to take off 10 root 7s. So that's going to be negative 4 root 7s. I've also got 14 take away 30, which is minus 16. So this is the base times the height. I'm just going to pop that here. Base times height is that. So area is half of that. Well, half of negative 4 root 7s is just negative 2 root 7s, and half of 16, half of negative 16, negative 8. So if this is 4 root 7s and I want half of them, well, that's only 2 root 7s. I'm not going to go halving that as well. And another little thing down here, 3 root 11 squared. Just show you how this works and then we'll show you the shortcut. That's the same as 3 lots of root 11 being squared. Remember that squared means multiply this thing by itself. So that's 3 times the square root of 11 multiplied by itself, which is 3 times the square root of 11. And multiplying is commutative. You can do it in real, whatever order you like. So instead of doing 3 times the square root of 11 times that by 3 and then times that by the square root of 11, I'm going to swap the order around. So I'm going to do 3 times 3 first, because that's fairly easy. That's 9. Root 11 multiplied by root 11, well, that's 11. So I just need to times those together and I get 99. So a shortcut really is I've done 3 squared and root 11 squared and then multiplied the result. So that's 9 times 11 gives you that. So for this sort of thing, shortcut perhaps would be I'm going to do 14 squared and I'm going to multiply that by root 3 squared. Well, 4 squared is 16. Root 3 squared is 3. 16 3s are 48. I'll put that there as well. Alright. So one last thing is called simplifying, or again, that's a bit vague. I'll talk about that a bit more in a minute, but we're going to simplify these. So you know the rule about root A multiplied by root B is equal to those two things multiplied together and then take the square root afterwards. So root A times root B, I can do A times B first and then square root. And this works in reverse. So root 12, I could write that as the square root of 4 multiplied by the square root of 3. And I appreciate that that's a weird thing to do, but it does mean that because the square root of 4 is a whole number, because I picked a square number, 4 is a square number, so its square root's a whole number, root 4 times root 3 is the same as 2 root 3. And you might remember from the first video that when I typed in root 12, it did give me, it said initially 2 root 3. So when you're simplifying like this, the thing is to look for factors of 40 and ideally find one that's, well, you need to find one that's a square number. So 40 is, well, it's 2 times 20, but neither of those are square numbers. It is 1 times 40, I suppose, and 1 is a square number, but that's just not going to get us anywhere. So the thing to pick here is 4 and 10. Again, so root 4, root 10, and of course square root of 4 is 2, so it's 2 root 10s. The square root of 40 is exactly the same answer as 2 lots of the square root of 10. Here's a slightly trickier one to spot. So 98. Can you think of a square number that's going to go into 98? Well, the one here is going to be, it's 49 and 2. So 49 times 2 is 98, and 49 is a square number. So this is the same as 7 lots of the square root of 2. And just combining things like this. So one thing that we're not going to fall into the trap of, we're not just going to go, well, 32 plus 128 is 150, 160. That's the square root of 160, because we know that adding up surds like this does not work. So it's not that, but we can do some of this simplifying first. So the square root of 32 is 16 times 2, so the square root of 16 times the square root of 2. And, perhaps a bit less obvious, but 128 is 64 times 2, and 64 is a square number, importantly, like that. Now I'm aware that means it looks worse at the moment, but root 16 is 4, so this is 4 root 2s, plus, well, root 64 is 8 root 2s, and then that together makes 12 root 2s. 4 root 2s, add on another 8 of them, makes 12. So root 32 plus root 128, even though you might not even know what those numbers are, it's going to be a bit less than 6 for that one, saying that's a bit more than 11. It's the same answer as 12 lots of the square root of 2. So very, very, very last bits are, why do we even care about surds? It's just because sometimes you'll be doing a Pythagoras question, for example. What's the length of that side there? And you're going to do, well, it's the hypotenuse squared, so a squared, b squared, c squared. A squared plus b squared equals c squared, so 40 squared plus 100 squared is the hypotenuse squared. So I need to do, let's just check, 40 squared is 1600 plus 100 squared is that. And if I square root that, I'm going to get the hypotenuse. So add on my 10,000, square root that answer, and it says, did you see actually, did you see, I don't know if you can see, it says, initially it says it's 20 root 29. Maybe that's happened to you before and you've gone, yeah, I don't care, I want the decimal. So it's 107.7032961, and that's not precise. That is, you're going to have to round that. And whilst in an awful lot of times it's not really going to matter, if this was some engineering thing and the length of that is supporting that, and you just go, oh, 107.7 will be good enough, then maybe it isn't. And if you're especially going to use that calculation or that answer to go and calculate something else, then you may well want to leave it in its surd form, or in exact form as it's sometimes called. And then the last bit is simplifying. And what does that mean? Well, again, it's a little bit vague, but simplify. So this sort of thing I've suggested you can go for. That is, what's that? 75 is 25 times 3. So it's going to be root 25, root 3, and root 25 is 5. So it's 5 lots of root 3. And certainly sometimes I've had students going, well, root 75, okay. I don't think that's simpler. That looks worse. It's got like 2 separate bits now. And I do have some sympathy for you. I kind of agree to some extent. But generally speaking, when we're simplifying a surd, what we're looking for is reducing the number inside the root. So here it's a 75. There it's only 3. And you've got to agree that's a lot simpler. So that's what we mean when we're talking about simplifying surds.